So very good noon. So we will wait for 1 to 2 minutes so that some of one will join. And we will discuss today's topics. So very good noon. So we will start with for our session for today's lecture regarding the EE1801 high voltage engineering. So previously we will discuss about the development of a potential breakdown in an extremely non-uniform field. So in this part, we will discuss the development of a corona in the extremely non-uniform field, the development of a star corona, development of a steamer at the canal discharge, and the development of a leader corona. Right. So in this lecture, we will discuss about the breakdown in an extremely non-uniform field and the corona, okay, where we will discuss about we will observe the particular corona effect in a non-uniform field above than the 100 kV. Okay, so it will often difficult and economically it will be non-viable to produce the apparatus free of a potential breakdown at normal working voltage. Okay, so it's in a normal working voltage, this particular effect will cannot be visible, okay, or cannot be viable, right? So how can we develop the star corona? So here today we will discuss this thing, right? So first it should be written in this case that if we will consider a point, or if we consider a needle or a plane electrodes, okay, as we can see in the figure, right? So if we will consider a normal electrode, okay, so filled in the gap, so here we will see a positive DC voltage which will be greater than the required for the producing the electric field to cause the impact ionization. So due to this impact ionization, what will be happen? So due to this positive DC voltage, that will greater than the required amount of electric field which will be required for the impact ionization at the tip of the needle electrode. Okay, so if I choose the plain electrodes, so at the needle of the electrodes, there will be the positive DC voltages which will be greater than the required number of electric, and that is required for the producing the electric field that will cause the impact ionization at the tip of the electrodes. Okay, so the electron, the plane electron being grounded, okay, as we know that, so the impact ionization grows in the form of a development in an avalanche process. Okay, and in the direction shows in the figure which I already I show you in the later on. So the avalanche process which will become the vigorous and then increasing the applied voltage. So whenever the applied voltage that will increasing in this particular process, avalanche process, so that will leads a partial of the local breakdown in the year on the year at a particular region where the field intensity in the dielectrics is higher than its required potential breakdown in section. Okay, so there will be the increase of the applied voltages due to the avalanche process. Okay, so for that cases there will be the leads of a partial of the local breakdown which will be occurred inside the year, or for a particular region where the field intensity in the dielectrics is higher than the required potential breakdown, right? So the local breakdown process leads to the development for the production of a very large amount of charged particles. So whenever we have a requirement of a very large amount of charged particle, so for that cases we have a local breakdown will be takes place, or take local breakdown will be leads. Okay, I think some of us okay. So, what is for the local breakdown process? So, the local breakdown process leads to the development for the production of a large amount of charged particles. So, due to this particular charge carrier, we will consider the different such kind of movement of electron or the positive ion. So, due to the avalanche breakdown, what is happened that the different kind of movement we will observe in the electron and as well as in the positive ion, which will leads the space charge formation. Okay, so whenever there will be some movement of the electron and the positive ion, so there must have a leads for the charge formation which will be created inside the cylinder or inside the hollow space, right? So since the resulting electric field in the gap depends upon the interaction between the field which will produce by the space charges and whatever the field, the electric field that will apply due to the applied field voltages, right? So it will be very dependent upon the what will be the polarity of the electrode. So if I change the polarity of the electrode, then what happen? The electric field intensity will be changes. So both the positive and the negative polarities are therefore considered separately. So if either we will consider the positive polarities or we will consider the negative polarities, right? So depending upon that, we will consider the polarity of the electrodes, and we will consider both the positive and the negative polarity in a simultaneously, considering separately, right? So what do you have when if I consider the positive point or the positive plane of electrodes configuration that we will show? So that thing we will show in this particular scenario. So in this particular cases, what will be the positive point plane electrode configuration uh, that we can see, right? That we can see. So in this process, it will be defined if the avalanche breakdown is formed. For that case, is the positive point electrode is analogous to one of the uniform field. So if I choose some uniform field, so what happened in this process? So avalanche breakdown between takes place, and that avalanche breakdown which will form the positive point of electrodes in an analogous form, right? However, if we have a field intensity of E, in such a cases, the electrode system which will fail close to the point electrodes. Okay, so beyond at a short distance, if I consider the distance between the two electrodes will be Ax, and if I choose a small distance between the two electrodes which will be the del x, okay, for that case is the field intensity falls below the minimum field required for the partial breakdown, supposed to be EI, right? So thus we can say that the strong space charges which will be formed inside the process, which will be able to extend itself as a maximum length of del x, right? So in this particular gap, if the del x will be shortened, so for that case is the critical amplification of a length required for the avalanche breakdown. Okay, so that thing we will show in the next figure. Okay, so I will show you the figure. Okay, then I will describe you what will be the going on inside the process when the positive, when we will consider the polarity of it to different type of electrodes. One is a positive polarities, another one is a negative polarities. Okay, so at a lower scale ratio diagram that we will show in the below figure. So I will show you the figure. Okay, in the next line it will be stated that at an avalanche stages, whenever the avalanche breakdown will be takes place, the space charges will be formulated, right? So the basic ionization process, whatever the basic ionization process due to the avalanche breakdown stages, okay, so that process will be considered once again. That means we are reconsidering our ionization process as the avalanche breakdown will takes place at a certain stage. Okay, so when a positive DC voltage we are applying to the particular point, supposed to be in an anode, if I applied the voltages, so the direction of the avalanches as we are shown in the figure. Okay, so now we have to show the figure so that you will understand what is going on, right? So this is actually okay. Is my screen is visible, Ravinder?
Yes, sir.
Okay, fine. So okay, one second, wait for a while.